Chapter 4 Trigonometry. This is a right angle triangle ABC where angle B is equal to 90. So, if angle A is equal to theta, we can write down the trigonometric ratios of theta, which is an acute angle. So, sin theta is equal to opposite side of angle theta upon hypotenuse, that is equal to BC upon AC. Then cos theta is equal to adjacent side of angle theta upon hypotenuse, that is AB upon AC. Then tan theta is equal to opposite side of angle theta upon adjacent side of angle theta, that is equal to BC upon AB. Now cot theta means the adjacent side of angle theta upon opposite side of angle theta, that is equal to AB upon BC. Then sec theta means hypotenuse upon adjacent side of angle theta, that is equal to AC upon AB. And cosec theta means hypotenuse upon opposite side of angle theta, that is equal to AC upon BC. Now, take the standard angles 0, 30, 45, 60 and 90. So this is the table showing all the trigonometric ratios. So first, sin 0 is 0, then sin 30 1 upon 2, sin 45 1 upon root 2, sin 60 root 3 upon 2 and sin 90 1. Now, to find out the cos, we have to come backward. So cos 0, 1, then root 3 upon 2, then 1 upon root 2, then 1 upon 2 and 0. Tan means sin upon cos. So tan 0 is 0 upon 1, that is 0. Tan 30 is 1 upon 2 upon root 3 upon 2, that is 1 upon root 3. Tan 45 is 1 upon root 2 upon 1 upon root 2, that is equal to 1. Then tan 60 means root 3 upon 2 upon 1 upon 2, that is equal to root 3. And tan 90 means 1 upon 0, so it is not defined. Then cot theta means we have to come reverse. So first not defined, then root 3, then 1, 1 upon root 3 and 0. Then sec theta. Sec theta means 1 upon cos theta. So sec of 0 is 1 upon 1, that is 1. Sec 30, 2 upon root 3. Sec 45, root 2. Sec 60, 2. And sec 90 is not defined. Now cosec theta means 1 upon sin theta. So cosec 0 is not defined. Cosec 30 is 2. Cosec 45 root 2. Cosec 60 2 upon root 3 and cosec 90 1. Now in a right angle triangle the one angle is 90 degrees, so the remaining two are complementary angles, and therefore sin 30 is equal to cos 60, tan 45 is equal to cot 45, sec 60 is equal to cosec 30. Now we'll learn the trigonometric ratios of any angle theta by using rectangular coordinate system. Here we have to take a point P, that is xy, where x and y belongs to R. Now draw seg PM, which is perpendicular to x-axis. The number corresponding to the point M on x-axis is the x-coordinate or abscissa. And if we draw a perpendicular PN to y-axis, then the number corresponding to the point N on y-axis is y-coordinate or ordinate. Therefore, by distance formula, OP is equal to under root x square plus y square. Now some more concepts regarding trigonometry. The first one, angle in standard position or standard angle. First one, directed angle. Here, ray OA is known as the initial arm, and if we rotate it in anti-clockwise direction about O, the final position of ray OA is ray OB, and therefore ray OB is the terminal arm. In this case, the rotation from the ray OA to ray OB defines an angle AOB, which is the directed angle. Here, angle POQ is not equal to angle QOP because both of them are having the different direction. If the rotation of the initial ray is anti-clockwise, then the angle is positive, and if the rotation of the initial ray is clockwise, then the directed angle is negative. No rotation means zero angle. In rectangular coordinate system, a directed angle with its vertex at the origin O and the initial ray along positive x-axis is the standard angle. So here the origin O is the vertex of angle in standard position. The amount of rotation of the ray from the initial position to the terminal position is the measure of standard angle. A directed angle in standard position is said to be in particular quadrant if its terminal arm lies in that quadrant. So here, arm OP lies in the first quadrant, so angle AOP is in first quadrant. Here, the angle AOP lies between 0 degrees and 90 degrees or minus 360 degrees and minus 270 degrees. Now here, the terminal arm OR lies in the second quadrant, so angle AOR is in second quadrant. Here the angle lies between 90 degrees and 180 degrees or minus 270 degrees and minus 180 degrees. Then, here the terminal arm OS lies in the third quadrant, so the angle AOS is in third quadrant. Here the angle lies between 180 degrees and 270 degrees or minus 180 degrees and minus 90 degrees. Here the terminal arm OL lies in the fourth quadrant, so the angle is in the fourth quadrant and it lies between 270 degrees and 360 degrees or minus 90 degrees and 0 degrees. Now, quadrantal angle, a directed angle in standard position whose terminal arm lies along coordinate axis is called a quadrantal angle. Here, angle AOB, angle AOC, angle AOD and angle AOA are all quadrantal angles. So, they are always an integral multiple of 90 degrees. Now the question, draw the figure and tell the answer. For the angle in standard position, if the initial arm rotates 220 degrees in clockwise direction, then state the quadrant in which the terminal arm lies. It will be in the second quadrant. It will start from here, then 90, then 180 and it will be 220, so it is in the second quadrant. Now next is trigonometric ratios in terms of coordinates of a point. Now this is the x-axis and this is the y-axis. It is the origin O. Let angle AOB is equal to theta is in standard position. Its initial arm is OA and the terminal arm is OB. Let PXY be a point on the terminal arm OB such that OP is equal to R, and therefore the trigonometric ratios in terms of coordinates of point P, X, Y are defined as sin theta is equal to y upon r, cos theta is equal to x upon r, tan theta is equal to y upon x where x is not equal to 0. Then cot theta is equal to x upon y where y is not equal to 0. Then sec theta r upon x where x is not equal to 0. Then cosec theta is equal to r upon y where y is not equal to 0. Remember, the trigonometric ratios do not change even if we take any other point on the terminal arm. Now, from these definitions we got y is equal to r sin theta and x is equal to r cos theta. Here, x and y are the Cartesian coordinates of the point P and r theta are its polar coordinates. Now, if we take the center of the circle at origin and radius is equal to 1, then the trigonometric ratios are like these. Sin theta is equal to y, cos theta is equal to x, tan theta is equal to y upon x where x is not equal to 0. Cot theta is x upon y where y is not equal to 0. Then sec theta is equal to 1 upon x where x is not equal to 0. And cosec theta is equal to 1 upon y where y is not equal to 0. Now the signs of trigonometric ratios in different quadrants are like these. In first quadrant, all are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. Now we'll see the trigonometric ratios of negative angles. For any angle theta, sine minus theta is equal to minus sine theta. Cos minus theta is equal to cos theta. And tan minus theta is equal to minus tan theta. Also, cot minus theta is equal to minus cot theta, sec minus theta is equal to sec theta, and cosec minus theta is equal to minus cosec theta. Now the question, find the trigonometric ratios in standard position whose terminal arm passes through the points 5, minus 12. Here x is equal to 5, y is equal to minus 12. Therefore, r is equal to under root x square plus y square, that is equal to under root 5 square plus minus 12 square, that is equal to 13. Therefore, sin theta is equal to y upon r, that is equal to minus 12 upon 13. Cos theta is equal to x upon r, that is 5 upon 13. Tan theta is equal to y upon x, that is minus 12 upon 5. So cot theta is equal to minus 5 upon 12. Sec theta is 13 upon 5 and cosec theta is minus 13 upon 12. Now about the trigonometric identities. The first one, sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta. And 1 plus cot square theta is equal to cosec square theta. Now the question, prove the following. Under root 1 minus cos A upon 1 plus cos A is equal to cosec A minus cot A. Now LHS is equal to under root 1 minus cos A upon 1 plus cos A, that is equal to under root 1 minus cos A upon 1 plus cos A multiplied by 1 minus cos A upon 1 minus cos A, that is equal to under root 1 minus cos A the whole square upon 1 minus cos square A, that is equal to under root 1 minus cos A the whole square upon sin square A, because cos square theta plus sin square theta is equal to 1. So 1 minus cos square theta is equal to sin square theta. That is equal to 1 minus cos A upon sin A. That is equal to 1 upon sin A minus cos A upon sin A. That is equal to cosec A minus cot A, because 1 upon sin theta is equal to cosec theta and cos theta upon sin theta is equal to cot theta. Therefore, LHS is equal to RHS. Now next we'll see the application of trigonometry. Here B is any object and the observer is at the location A. So, if the observer is looking at the object B, then the line AB is called the line of vision. Now, the position of the object is changed and B is at a higher position. Then, so if the observer is at point A, then AB is the line of vision. Here AM is the horizontal line and therefore angle MAB is the angle of elevation of B with respect to line AM. Now here, suppose the object is at a lower position, that is at position B, and A is the position of the observer. Then A is at higher level than B and AM is the horizontal line through A. Then angle MAB is the angle of depression of B with respect to line AM. So when you look up, it is the angle of elevation. When you look down, it is the angle of depression. Now the question, a tree is broken by the wind. The top struck the ground at an angle of 30 degrees and at a distance of 30 meters from the root. Find the whole height of the tree. Root 3 is equal to 1.73. Now let BD is the tree. The tree is broken by the wind at point C. So now this portion touches the ground at A. The angle is 30 degrees. So measure angle BAC is equal to 30 degrees. The distance is 30 meter from the root and therefore length AB is equal to 30 meter. So here let BC is equal to X, CD is equal to Y. Now CD is equal to CA, therefore CA is equal to Y. In right angle triangle ABC, we have tan 30 is equal to BC upon AB, that is equal to 1 upon root 3 is equal to X upon 30. Therefore, X is equal to 30 upon root 3, that is equal to 30 root 3 upon 3. That is equal to 10 root 3. Now cos 30 is equal to AB upon AC, that is equal to root 3 upon 2, that is equal to 30 upon AC. Therefore, AC is equal to 60 upon root 3. Therefore, Y is equal to 60 upon root 3, that is equal to 60 root 3 upon 3, that is equal to 20 root 3. Now, height of the tree is equal to X plus Y, that is equal to 10 root 3 plus 20 root 3, that is equal to 30 root 3 meters. But root 3 is equal to 1.73, therefore height of the tree is equal to 51.90 meters.